Today we're going to use factoring strategies to be able to factor these trinomials. Let's take a look at the first problem here. And my first strategy is always to look at each of the terms and see if I can make it an easier problem. And I see that each of these has a factor of 3. So if you ever look at all the numbers and you see a common factor, take that common factor out and see what's left over, because it's going to be a whole lot easier to factor than the original problem. See, the thing you have to remember, though, is to always make sure you bring down that common factor. And so now I've got a trinomial that just has x squared minus x minus 2. So draw my two binomials, and I'll put x and x to make the x squared, 2 and 1 to multiply to make the 2, but now I need to get that sign right. See, I know that the outside and inside terms need to subtract to make a 1x, and actually it needs to make a negative 1. And so in order to subtract to make a negative 1, that means I need to make the 2 negative and the 1 positive. So negative 2, a positive 1, and that will end up working out. And so when you write your answer in your answer box, make sure you write down the 3 in there as well. So 3 times the difference of x and 2, and that's being multiplied by the sum of x and 1. So there it is. Well, taking a look at the next problem, we have no common factors. 19 has no factor of 5, which these two do, so we can't take out a 5. So as I do this, I'm looking at that last digit's sign, and it's negative, which tells me the outside and inside terms are subtracting to make a 19x. So I'm going to draw my two parentheses, and my first inclination is to go ahead and break this 15 down. I'm going to break it down because if I used 15x and 1x, I think I'm going to end up multiplying by a factor of 10, which would give me something too big to subtract to make 19. So that's the reason why I'm trying to go with a 5x and 3x to start with. So now I'm going to go ahead and try some numbers that multiply to make this 10. So we can start with 2 and 5. If that doesn't work, 5 and 2. 1 and 10, 10 and 1. Now if none of these work, then we'll cross it out and try 15x and 1x. So we'll try the first one here. 2 and 5, and check those outside terms. And these make 25x. Inside terms make 6x, and we can get those to subtract to make 19x. So it does end up working out. Now in order to get a positive 19, it means I needed a positive 25 and a negative 6. So we put the minus sign with the 2, the plus sign with the 5, and that will end up working out. So 5x minus 2, and we have a 3x plus 5. Well, let's take a look at the next one. Same sort of thing as the first one. You see how that we have a negative x squared term? Well, I don't like to factor with the negative x squared term. You could factor with it, but if you could get rid of it, then I can use my rule of looking at the last digit sign, and that's what I'm going to do. So I don't see any other common factors, so I'm just going to take out a negative 1 from each of these terms. And so when I see a problem like that, first thing I do is I go ahead and take out the negative 1 as I write down the problem. So what that will do is it'll switch all the signs, and then from there I look at the last digit sign. So now I can look at the last digit sign and then use my rule. If it's minus, I subtract the outside and inside terms, and I end up with the middle term, 18x. So I go ahead and I think to myself, well, I'm pretty sure I'm going to end up having to break that 9x squared down to 3x and 3x. But if it doesn't work, I can always redo this and try it again. Now notice that I brought down that minus sign. Always bring down any term that you factor out. And now we'll think of numbers that make 16, multiply to make 16. Remember, outside and inside terms are subtracting to make the 18. So I think I need to have an 8 and a 2. That's my guess. If that doesn't work, well, we can always try the 4 and the 4. And we got 16 and 1. So those are different options. I don't need to try 2 and 8 and 1 and 16 because the coefficients in front of the x terms are the same. So we'll try an 8 and a 2 and see what we come up with. So we got a 6x. Here we've got 24x, and those two numbers do subtract to make 18x, so it does end up working. So we want a positive 18, so that means I'm going to put a plus 24 and a minus 6. So plus 24, minus 6, and we've got our answer. So make sure when you write the answer, put that minus 1 or minus sign down, the 3x plus 8, and you'll have a 3x minus 2. And there is our answer. Well, taking a look at the next set of directions, it'll ask us to Determine whether each trinomial is a perfect square. If so, factor. If not, explain. Well, first thing we're going to look at is when a factoring strategy, especially in a problem like this, is to look for perfect squares. If you see this is a perfect square, and you see this is a perfect square, check. Take their square roots. See what the numbers would end up being. So if I take their square roots, this first one's going to end up being 4x. So if it's a perfect square, that means they're both going to be 4x. Take the square root of 25, that's 5. It means if it's a perfect square trinomial, that means they'll be the exact same binomials. So it's got to be a -5 and -5 because the middle term here is -40. So let's just check. Check the outside terms. Check the inside terms. They're going to be the same with trinomial square. See if they make 40, and they sure do. So yes, this does end up factoring as two binomials that are exactly the same. So that is a perfect square trinomial. Well, taking a look at the next one, I have the same situation. See, this is a perfect square, and this is a perfect square. So we could go ahead and try the square roots of those numbers inside the two binomials. And so this would make a 5x, and this would make 2. It's got to be a minus sign because of the minus sign right here. And another 5x and 2. That's what it would have to be if it's a trinomial square. So let's check it. And so we go ahead and multiply. Here we get 10x, negative 10x. This is a negative 10x. And those add to make negative 20x. Ooh, no, it doesn't work. See? That is 10x. It's not the same as this one. So we would say no. The reason is that the middle term should end up being negative 20x. So should be negative 20x, not negative 10x. So always check those outside-inside terms to see if they work. Now, this next one's a tricky one because we see that this is not a perfect square. But don't give up. See if there is a common factor between these terms. See, I see a common factor of 2. And so if I go ahead and do that division, now I've got x squared, which now is a perfect square, minus 6x plus 9. And 9's a perfect square as well. So let's go ahead and factor and see if we can factor it as a trinomial square. And so they're both perfect squares, so let's go ahead and try their square roots inside the two binomials. Now again, another minus sign, so x minus 3x minus 3. It's a minus sign because of this middle term being negative. If that was a positive 12x, then we put plus sign instead of a minus sign. So check those outside terms, inside terms. See if the product of those two values that we took the square roots of, doubling that equals the middle term, which it does. See, it makes a negative 6x, so it works. And so we can go ahead and write the answer down as 2 times the product of x minus 3 quantity squared. And there it is. Well, part 2 will have the other 2 types of problems we'll end up seeing on tonight's homework.